Hello, welcome back to Learning with Ms. H. Today we are going to be looking at our finding the epicenter of an earthquake activity, and you are going to be doing just what it sounds like. You're going to be locating the epicenter of several earthquakes. The lesson for today is right here. So your bell work, explain the relationship between an epicenter and a focus of an earthquake. So go ahead and pause the video, answer that bell work, grab your note-taking supplies if you have not done that already, and then come back when you are ready to take notes. All right, welcome back. We're going to look at the notes over how to use the triangulation method to locate the epicenter of an earthquake. So let's full screen this. So triangulating the epicenter of an earthquake is not a difficult process once you get it figured out, but until you do, it's a little bit tricky. So first thing you need to do is you need to be aware of some of the background terminology. So we have seismic waves. Those are the vibrations that come out from the focus in all directions. So if you were to, say, look at these circles in the background of the slides here, the focus would be in the middle of this circle, and then the seismic waves would be these circles that are emanating out from it. So remember that the focus is underneath the surface in the internal layers of the earth, and the epicenter is on top. It's on the surface of the earth. So the focus is where all of the body waves and the energy go out from. Body waves travel in all directions from that focus. They go through the body of the earth. That's why they're called body waves. Surface waves are going to move along the surface, and those are going to be coming basically from the epicenter area. Remember, as we're going through these, you can pause the video at any point in time if you need to catch up on a slide before you move on. So in order to locate the epicenter of an earthquake, you're going to have to get a little bit of data. We use what's called a seismograph in order to gather the data from all of those seismic waves. So we're measuring the waves. We see how strong they are, how long it takes to get to the seismograph, and then the amount of time in between those waves. We get all that information together. We put it on a map. We use 3 different stations at 3 very different locations so that we can triangulate and locate the epicenter of the earthquake, where it started from. So in triangulation, we use data from 3 different seismic stations. Triangle has 3 corners, so we're going to use 3 different stations, and we basically make a triangle and use that to locate the epicenter. So where all 3 of the data from the stations meet, that's where the epicenter is. So we're going to look at the data from the seismographs and interpret that, put it on a map. This is what the data looks like from the seismograph. This is called a seismogram. We're going to talk about how to interpret this on some upcoming slides, but basically you have all of these waves coming across. So the machine is going to draw this line until it actually detects the first wave, the first seismic wave, and then it's going to have the spike, and you're going to have these bigger zigzags. So this is your P wave showing up. Remember that the P wave travels faster than the S wave. So the first one is the P wave, and then you get a larger spike when the S wave gets there, and then you have these larger zigzags here. So we're going to look at how to interpret this, but basically you're going to see where the first spike is and bring it down to your timeline. Where your second spike is, bring it down to your timeline, and then we're going to measure, we're going to determine how much time is in between here. So you again have to have 3 different seismic stations. The P waves travel faster than the S waves, and we're going to be looking to determine the lag, so the amount of time in between the S wave and the P wave. So lag time is that difference. You are basically going to figure out how much time is in between, and we're going to use that information, put it on a graph, and then that graph is going to tell us how far away the earthquake is based on that lag time. So here's how you calculate lag time. Your P wave gets there first, your S wave gets there second. You're trying to find the difference in time. So you're going to take your S wave minus your P wave, and that's going to equal your lag. So if we have an example where our P wave arrives at 10:42:03 and our S wave arrives at 10:43:23, we would take S minus P, so 10:43:23 minus 10:42:03, and the difference is 1 minute and 20 seconds. Our time format is always hour, minute, second. If there's only two, it's typically going to be hour, minute, but it should indicate on there if there's only two, whether it's hour, minute, or minute, second. So you just, if you line them up on top of each other, 23 minus 03 is 20 seconds, 43 minus 42 is 1. If you ever get to a point where you maybe had the 03 on top of the 23, you would take your minutes, subtract 1 minute, and add 60 seconds. So this would end up then being a 63 and a 1. We'll show an example of that later. For now, S minus P equals lag. So when you're collecting data from the recording stations, your first spike again is the arrival of the P wave, the second one is the arrival of the S wave. So in our example here, we drop a line straight down from the P, and that's our green information up here, and that's going to be 3:02 and 20 seconds, so 3 hours, 2 minutes, so 3:02 p.m., and then each one of these hash marks is 20 seconds long, so 20, 40, 60 seconds is a minute. So the P is directly above 3:02:20. We're going to do the same thing for the yellow, for the S wave. That is at 3:06, and it's halfway between the 20 and the 40, so it's 3:06:30. Let's do it the same way every single time, every single station. So if we are looking at an example where we are at station A in Oklahoma City, Oklahoma, we have our P wave arrival time at 3:02:20. Our S wave arrival is 3:06:30. So we're going to calculate the lag time there. So what I'd like for you to do is go ahead and tell me that time difference. Pause the video, calculate the lag time, and then move on to the next slide. All right, hopefully you did that, and you figured out that your lag time is 4 minutes and 10 seconds. So you subtract that out. 30 minus 20 is 10. 6 minus 2 is 4. 4 minutes, 10 seconds. Go ahead and jot that number down. You're going to need it later. So Oklahoma City, 4 minutes, 10 seconds. Station B. Take a minute, pause the video, see if you can figure out the arrival times for each of the waves here, and then keep going with the video. All right, so hopefully you figured out that the P wave arrives at 3:01:40. The S wave is 3:05:00. And this station is in Denver, Colorado. So again, I'm going to have you go ahead and pause the video and figure out that lag time. All right, lag time here, 3 minutes, 20 seconds. So Denver, Colorado, 3 minutes, 20 seconds, jot it down. Our last station, go ahead and pause, figure out the arrival times. Excellent, now that you've figured out the arrival times, you're gonna go ahead and do the math and figure out the lag time. Label this Missoula, Montana, and jot down your lag time once you've got it. All right, hopefully you determined that your lag time is exactly 2 minutes on this one. So now we're going to take all of this data that we just gathered, and we're actually going to put it on a graph. So we're going to take a time distance curve, and we're going to use our lag time information that we just calculated to figure out the distance that the earthquake is away from that seismic station. So how far away is the epicenter? So this is the graph we're going to use. And you're going to need a second piece of paper. If you're doing this on paper, you'll need this graph printed off, a second piece of paper, a note card, a sticky note, something small that you can put little hash marks on. And what you're going to do is you're going to set that second piece of paper right here on top of it. And you're going to make a mark for the 0 down here. And you're going to make a mark at your 4 minutes, 10 seconds, because that's our first lag time. Once you've done that, you're going to take this piece of paper that's on top and you're going to move it across this graph so that the top line lines up with the S line on your graph and the bottom line lines up with the P on the graph. So we're going to move this blue piece of paper, which is our top piece of paper, until it fits and matches up. So the top hash mark is on the S wave line and the bottom hash mark is on the P wave line. And then you're going to drop a line straight down from there to see how far away it is. So this is a distance of 2,800 kilometers because each one of these vertical lines is 200 kilometers. Each one of the horizontal lines is 20 seconds. So at 4 minutes and 10 seconds, it's 2,800 kilometers away. And make sure that you are aware that it is measuring it in kilometers, not miles. So we're going to go ahead and do this for each one of these three. And this is what we get. 2,800 kilometers, 2,000 kilometers, and 1,100 kilometers. So we're going to take this information with the distances, and that's what we're going to put on our map. So now we know the distance between the epicenter and each city that recorded the data. We're going to draw a circle around each city and use those circles, those distance circles, to see what the radius is. So our radius is going to be those numbers, and we're going to see where they overlap. The point where all three meet is the epicenter. You can do this on paper, but you'll need a map that's to scale. And you're going to need a compass, which is the little tool where one end is a point and the other end is a pencil, and you can spin it in a circle. So if you don't have those, this digital map is an easy way to do it. So this slide's going to be instructions on how to use the digital map. And then the last slide is information for your lab. So you have a seismic wave travel time versus distance graph. If you click this, it's going to make you make a copy of this document, and this is a document that once you make your copy, you can manipulate it and move things around on it. So this green box, you will be able to move, and what you're going to do is when this loads, you're going to put the green box down here so that the bottom of the box is on 0, and the top of the box you're going to put wherever your lag time is. So you can zoom in on this if you would like. Go view. And actually we can just use this little plus sign to zoom in on it, and then go back to your arrow, and you can adjust the box to 4 minutes, 10 seconds, and then you can drag it along until the top of the box is on the S wave and the bottom of the box is on the P wave. So that's how you're going to use that. And then you will figure out where that's going to be. And that is going to be your distance away. So right about there, you've got top and bottom lining up with it. Extrapolate it down, 2,800 kilometers. So that's that tool. You have your homework assignment clicked here. That's going to be a link to your homework document that you're going to make a copy of. And this is going to be your homework that you're going to do. And then the video explanation will be a link to this video. So let's go back up here. This is the instructions for how to use the map site. So if you click this link right here, this link takes you to this map site. So what you're going to do, this is instructions on how to do it. Basically, you're going to come in here to the address and you are going to type in your first station, which is Oklahoma City, Oklahoma. Our radius was 2,800 kilometers. So 2,800 for the radius, and we're going to change this over to kilometers. We've got a color here. We're going to check only show the border, and we're going to put new circle. And that is going to pop us over here to that location, and it's drawn the circle for us. So our second set of data was Denver, Colorado at 2,000. So then we're going to come back in here. Denver, Colorado, 2,000 kilometers. I'm going to change the color so it's a different color so it stands out a little bit. Let's make it red. New circle. So now we have two circles on the map here. And you can see, oh, I just added a new circle and didn't want to. So while that circle is highlighted, I can come up here and click remove circle and it'll pull it off. You can also edit circles. So if I wanted to change the color, if I didn't like the color it was, I can change it to a green circle and click edit. Make sure that you have a circle selected. Edit circle, and now that one's green instead of black. So then you're going to do your third station, Missoula, Montana, which is MT, and it is 1,100 kilometers. Let's make this one purple, new circle. And now you can see if we zoom in here, you can see here's all three circles. The green and the red overlap for this stretch here. The purple connects to each of them a couple places here, but what you're after is this location where they all three meet. So all three of them meet right here at this point, right where my hand is here, just west of Portland out in the Pacific Ocean. So that location where they all three meet, that is the epicenter of your earthquake. Okay, once you've done that, you're going to come back in here, you're going to post a picture of your map, and you're going to answer the questions about it. So how do you get the information? Here's an example set of data. You would get your lag times here from doing the math. So it would give you the P wave, the S wave, and you do the math on the lag time, determine the distance using the graph that we just did, show your map, answer the questions. And you're going to do that for each one of these. It's going to give you the P wave and the S wave, and you're going to determine lag time, distance, answer the questions, insert your map. That is the first few sets of data. Once you get down here to data set 4 and 5, you're going to have to actually determine the P and the S arrival times on your own. So you'll see the city name on the seismogram. You're going to determine the P wave and the S wave, calculate the lag time, find the distance on the graph. So you're doing all of it now on these last two. This page is blank because the insert your map is at the bottom of this. So I'm assuming that as you type into this, you're going to be increasing the space and you're going to need this page for your map. Here's data set 5, and then the graph for data, or the table for data set 5. So each data set starts its own page, and it's set up as a page break, so it will start its own page. So make sure you do all 5 sets of data when you do this. That is your Find the Epicenter assignment. So you have this page that you're going to go turn everything in on. And once you do that, you will be good. Done for the day. Hope you enjoy the lab. We'll see you next time.